All right, welcome everybody to another live stream, 2 nights in a row. Last one, I went over the quiz on our first part of our applications in trigonometry. And today I am going to go over vectors on a plane. So we're kind of switching gears away from triangles, but we're not going to get completely away from triangles, as you will see here on the live stream. So I will post these answers on my YouTube membership, and I see the Kitty Gamer is asking about the homework. I am having issues on my school website for my own students to be able to access the homework. And so I'm not sure what is up with that, but I will make sure, because every single time I post it up there, it seems like it gets deleted, and I'm not sure what the case is. So what I am going to do then is just make sure that I have it also uploaded on my website, which I have been a little bit behind on, so I do apologize for that. But that is the first I am hearing of it, so now I'm aware. I will make sure I post it on here, but unfortunately I didn't have time to see that before we get in there. So what we're going to cover, guys, is basically like what we did today in class. We're going to cover finding the vectors, or writing the vector in component form, identifying the magnitude, and then sketching the vector in component form, and then the angle of and also determining the angle of the vector. And then we're going to work with some operations of vectors. So hopefully this shouldn't take too long. I mean, obviously I will talk about things. We'll do some multiple choice questions as well. And then obviously I'll get to your answers or your questions that you guys have in the meantime. So see Harman and Fausto and Rita. Good to see you guys. Do with the content. Fausto, if you have questions, feel free to type them in. I'm not going to get to the questions exactly right now, just because I'm going to get started on this homework. But please feel free to type in those questions, and what I'll do is I will come back, and I will hopefully have some time here on my stream to be able to answer some general questions. So whatever questions you guys have outside of what I am covering in this live stream. So I'll be happy to do those, but I am going to want to make sure I get through the homework first. And then obviously I will take a break after I'm done on this first page. If you guys have any questions on this content, I will try to address them. And I don't know your name, but it says, do you have videos on 7th grade math? Yes, I do. If you just look in Algebra 1, I have a ton of videos. So if you go to my channel under playlists, I have a whole bunch of Algebra 1 videos. They're not per se for 7th grade Algebra 1, but Algebra 1 is Algebra 1. So they're basically content that hopefully should be able to help you out on that. All right. Jordan saying, is this for university students? Well, again, it depends. It doesn't matter. It depends if you're taking pre-calculus at university or if you're taking it in high school. I teach high school, but obviously if you're taking pre-calculus or linear algebra, something with vectors, this could be useful or maybe as a brush up for you. So, all right, let's go ahead and get started. So what we have here is we have an initial point and a terminal point, which is represented by the vector. Now, I didn't really write the vector on my thing correctly, so I'm just going to make sure that there's how we have them written. All right, and so there is your vector. Now it's a very important with vectors is that they are a directed line segment. So they have a initial point and a terminal point, and the first letter is your initial point and the last letter is your terminal point. So let's just go ahead and plot the point 1, 3. So I'm going to go over 1, up 3, 1, 2, 3. I'll just label that as L. And then I'll go to M, which is going to be at 5, 1. 1, 2, 3, 4, 5, 1. Okay. Now it doesn't say actually sketch given the following vector, sketch and then determine that. Okay, so let's go ahead and sketch the vector. So there's the vector. Now notice the arrow is in front of the point, right? So you have a condense here that's going to be broken down. Now, the next thing that we're going to need to do is go ahead and identify what the component form is. So basically the component form is just another way for us to be able to write the vector. It's just another way for us to write the vector where the initial point is going to be at 0, 0. And you'll see that's going to be very helpful for what we're going to do. So a lot of times students have trouble with this, understanding this, but basically writing the component form is just basically identifying the change horizontally and the change vertically, right? So if we were to think of these as like two components, L1 and L2, and this as M1 and M2, the change horizontally of these coordinate points is basically just going to be M1 minus L1, right? And if you think of these like X's and Y's, like the X, the second point, 5 minus 1, is going to tell you how far you're changing horizontally. And then if we want to change the vertical, it's going to be M2 minus L1. So it's basically the y-coordinate of your terminal point minus the y-coordinate of your initial point. And that's basically going to give you your component form. So for this one, I kind of draft that up. Let's go ahead and see here. M1 in this case is going to be 5 minus 1. And then M2 is 1 minus 3. Okay, so therefore we can simplify this into 4 comma negative 2. So now when we go ahead and graph this is very important. It's very interesting to see. The initial point of component form starts at the origin, which is 0, 0. And then that goes over 4, 1, 2, 3, 4, and then down 2. So what you can see here is this vector LM in component form has the same length as my initial vector, right? And it also has the same direction. The only difference is my initial point is at 0, 0. And that helps when we're doing our mathematics for this. For instance, one of the mathematics we need to find, so we just found the component form, so that's A. One of the mathematics we need to do is find the magnitude, which is basically the length. Now, you could figure out the length here because you can see I kind of created a triangle. But we could recreate that same triangle right here. And you can basically just count the squares, 1, 2, 3, 4, and then you can do negative 2. So obviously you can see that those sides of like the squares are basically your two components. And so the magnitude of PQ, I'm sorry, I don't know why I keep on doing it, of what, LM? Yeah, the magnitude of LM, and kind of like the double bar is our notation here for magnitude, which again represents the length, is basically just going to be the square root of 4 squared plus negative 2 squared, right? And basically we're just doing the Pythagorean theorem. So that's going to be 16 plus 4, which is 20. And I'm just going to leave that as the square root of 20. I'm not going to simplify that at all. In a lot of this chapter, it's not really going to help us to simplify things. So unless your teacher asks for it, then obviously you're going to simplify it. I give my students a break on simplifying the radicals and say it doesn't give us much advantage in this chapter, so let's leave it there. And then the next thing is let's go ahead and find the angle. Well, we have two sides, and we know that this is creating a right triangle, so therefore we can call this angle, let's just call this angle theta, right? Well, we can figure out what theta is. So let's see, C. So we could say the tangent of theta is equal to the opposite over the adjacent. So therefore theta is equal to the tangent inverse. Now I could rewrite this as a negative 1/2. You don't have to. You can leave it as negative 2 over 4. But let's see what that gives us. So I'll do tangent inverse of a negative, oops, that's not a negative, negative 0.5. And when doing that, I get a negative 26.57. So rounding it to the nearest degree here, I get theta is equal to a negative 27. No, sorry. Yeah, 27 degrees as I round to the nearest whole, which I didn't say to do. So that's my bad. But either way, you can see that that's the angle. Now, that's angle in theta. But what we have to do is we have to understand where this vector is. Now, again, actually, using the inverse function there, that gives us a negative angle, which doesn't make sense in terms of the triangle, but it actually makes sense in terms of standard form, right? Because standard form is going to be from the positive right angle to there, which would be our negative angle, right? So we could do it that way, or we could also use the positive version. And we could also just say, 360 minus 27, which I could probably just do in my head, which would be 333 degrees. Okay, so in case if you're doing a multiple choice and like both of those were answer, or one of those was an answer, then you just want to make sure you understand that they are equivalent, right? One's the positive, one's the negative version. All right, so let's go ahead and move on to the next vector. So in the next vector, we have a point in negative 4, 0. There's D. And then we have negative 1, negative 4. Negative 1, why did I do that? Negative 1, negative 4. 1, 2, 3, 4. So that's going to be E. So it looks like I picked this again to You know what? Let's change this. Let's go from E to D. I'm going to change this. Since I guess my homework was never up, we're going to go from there. And let's change that. Oops, crap. Yeah, because actually when I did my homework up here, I actually forgot to write in which direction they were going, what is the directed line segment. I just left the D and E. So if anybody did get that printed before, I guess, my online site took it down, they wouldn't have known, should we do D to E or should we do E to D? So I am going to just change this. So let's do E to D. So in doing E to D, we know that the direction now is going this way. Okay, so there's your initial point, there's your terminal point. So this is going to be our initial point, E is our initial point, and here's our terminal point. So again, when we're doing this, you don't have to label this D1, D2, E1, E2. You just know that this is your initial, like initial. Here's your terminal. So again, when you're trying to find component form, you're basically subtracting you have X and Y coordinates. So you're finding the change in the X coordinates, which will be terminal minus initial. So that's going to be -4 minus -1. Make sure you're using parentheses there. And then for this one, it's going to be the change in the Y coordinates, which would be, again, 0 minus -4. Oops. That's going to be a directed segment there. Okay, so now we can go ahead and get this, and this is going to be a -3, +4. So now to go ahead and graph that, I go -3, 1, 2, 3, and then up 4. 1, 2, 3, 4. Okay, so there's your E, and there's your D. So now that is my vector sketched in component form. Forgot to put that X there. The next thing would be to find the magnitude. Now, the nice thing about this, guys, is I noticed that this is a 3, 4, 5 triangle, right? This is 3, this is 4. So guess what? The magnitude of ED is really easy to find, right? That's a Pythagorean triple. So I'm just going to say that is going to be 5 units. I don't even need to apply this formula here. That's a 3, 4, 5 triangle. And then part C, which would be finding the angle. Well, I have enough information to figure out this angle, right? So let's go ahead and figure out that angle. So to do that, I would do the tangent of theta is equal to 4 over, oops, that's a -3. 4 over -3. So therefore, theta equals, so we'll do the tangent inverse of a -4 divided by 3, or 3 divided by -4 divided by -3, doesn't really matter. And that gives me a -53 degrees because this angle is in the second quadrant. But again, we need to understand that theta is going to be the positive version in terms of a triangle. So therefore, this is going to be 53 degrees as I round to the nearest whole. But it's important for us to understand, guys, that we're using this inverse here, that this is, it's going to be a positive angle. It's not negative, right? It's part of inside this triangle. What your tangent inverse is doing is it's giving the angle down here, which applies within the inverse trigonometric functions, if you remember that from our class. However, that is not the angle of the vector. The angle of the, sorry, not the vector. The angle, yeah, the angle of the vector. The angle of the vector is from standard form, which starts on the positive x-axis and goes to here, right? So basically, the angle is going to be 180 degrees minus theta. So I'm just going to take 180 minus 53, and that's going to give me 127 degrees. So that is going to be the angle of the vector. So in this last example, it was nice because the tangent inverse actually gave us the negative version inside that quadrant. However, this one we have to be a little bit more careful for because it doesn't give us the angle in the second quadrant because that doesn't fall within the restrictions of tangent inverse of our calculator. So therefore, we just have to understand what we're looking for and then obviously use supplementary angles to be able to figure the angle of the triangle. All right, so let's go ahead and get into the operations of vectors, and then for all of you guys that have joined in, I will get to kind of clarify any questions for you guys before we get to the multiple choice. All right, so let's go ahead and simplify given u 3 comma 4 and v negative 2 4. So you can notice that these two vectors are in component form, and rather than calling our vectors like lm with the little symbol, we're just giving them variables u and v. So I'll just kind of work on these a couple different ways. Let's go ahead and graph u and v. Just actually, you know what? Yeah, let's do it this way. Let's do. So what I told my students to do is instead of subtraction, we'll just rewrite this as addition. So u plus negative 1 times v. Okay? So when we're looking at u, so u is basically 3 comma 4. And then it's going to be plus a negative 1 times v, which is negative 2 comma 4. So as I continue doing my work down below, that's going to be 3 comma 4 plus 2 comma negative 4. All right, so now when I add them, so when you actually have to add vectors, you just add the first two components, or the x component, and then add the second components. And again, adding is really adding, subtracting, depending if they're positive or if they're negative. So therefore, this gives me 5 comma 0. All right, so let's go and kind of take a look at this, and what we're going to do is use the tail to head method. So what we're going to do is we're going to treat this. So we're going to write this. So this is technically u, and this is plus negative v, right? So let's just go ahead and graph u, which is 3 comma 4. So 1, 2, 3, 1, 2, 4. Okay, so there's my angle u. And then my vector negative v is 2 comma negative 4. So over 2 down negative 4. Okay, so there is negative v. Now when I add these together, or when I do a tail to, actually, you know what? Let's do this a different color, because I think that will make sense. Let's do this in purple. So that's at 2, negative 4. Okay, so there's negative v. Now, the resultant vector we figured out to be 5 comma 0, which I'm going to give green. All right, so what I was showing my students today was we can use the algebra to find the resultant vector, 5 comma 0. And then basically what we can do is we can take the, when you have a vector, you know, like this. This is what we call the tail, and this is what we call the head. To graph this, or to geometrically kind of see how this is happening, you can basically just take the tail of one of your vectors and then add it to the head of the other vector. Now, we don't need to do this for both vectors, like so you get this parallelogram. But what we can do is that is just a way. So I'm going to only do this once from now on. But you can see here, that's how we can identify our resultant vector, u minus v. So u minus v is our answer, and then basically I am just showing how adding vectors, which is basically just taking the tail of one vector and putting it to the head of the other vector, also takes us to our resultant vector. So I'm showing the addition graphically as well as algebraically. All right, so what happens then when we demultiply it by like a negative 2u? Like, what is happening here? So let's just go and look at the vector u. So u is at 3 comma 4. So 1, 2, 3, 4. Uh-oh, I'm not going to have enough space here. But there's u. All right, now that's my vector u. So if I wanted to do a negative 2u, then that's going to be negative 2 times the vector negative 2 comma 4. And when you have a multiple outside a vector, you're basically just distributing that to give you 4 comma negative 8. So if we look at this, that's wrong. What happened here? That's 4 comma negative 8. Oh, I was doing the wrong one. 3 comma 4. Crap. That is 3, 4. And then I wrote in the wrong one. Shoot. I was looking at V. I got them mixed up. All right, so this is 3 and 4. So therefore, this gives you a negative 6 comma negative 8. All right, now I don't have enough room for this to go down, but what you can see is if I was just to do negative u, like let's just do negative u, that gives us a negative 3 comma negative 4. Actually, let's do this in a different color. Let's go back to that green. So if I was to do negative u, that's going to be a negative 3 comma 4, which is a negative 3 comma negative 4. So it would be negative 1, 2, 3, down 4. So there's negative u. And if I'm doing 2, negative 2u, right? Well, that's going to be a negative 6, negative 8. So 5, there's 6. So this is 6, 7, 8. So you can see here that this vector is a negative 2u. So it's double the length of u, and the negative you can see is actually reflecting it about the origin, or going in the exact opposite of a direction. So that's what the negative does. It kind of goes in the opposite direction, and then you can see that scalar basically, either expands, multiplies like the length of the vector, or it could also shrink the length of the vector. All right, so let's do this last one here. Let's try to do this one maybe a little bit quicker now. Hopefully you got a general idea. So in this case, I have 2u plus v. So the first thing I want to do is just go ahead and figure out what u is, which is 3 comma 4, and then plus v, which is negative 2 comma 4. All right, so now I can distribute. So therefore, I get a 6 comma 8 plus a negative 2 comma 4. And again, I chose some numbers that is now going to go off of the grid, but that's okay. When I add these together, I get a 4 comma 12. All right, so first, I kind of know what my resultant vector is, right? It's 1, 2, 3, 4, and then up 12, which is going to be really, really big, like way up there. All right, so let's go ahead and graph our two vectors here. Let's do 6, 8. So 6, 8. 6, 7, 8. This isn't the best one. So that is my 2u. And then if I was to go from here to go up to there, basically if I'm going over negative 2, which would be like this way, negative 2, and then basically up 4, right? So it's like negative 2, up 4. Like that takes you to my tail to head method, which is my vector v. So you can see by just like adding one vector to the next, that is how you can add your vectors. So that is my resultant vector, which is 2u plus v. Let's maybe try that one more time. That's it's so hard. All right. Either way, hopefully, jeez, come on. All right, so there you go. That's at least what I'm expecting for my students to be able to show how the sum is working. I probably should have picked some better numbers to keep on the graph, but there you go. That's what it is. We have the algebraic as well as the graphical approach. All right, so we have some word problems that I'm going to get into real quick, and feel free to go ahead and work on those. I'll kind of see if there's any questions anybody wanted me to elaborate. See a couple people here, Victoria, Mariko, Bavith, sorry, Alvida, Jordan, Miguel, Vadim, Fausto, 29. You guys talking about some numbers, so let's, so by dum dum. Jeez, okay, get in there. A plus, well, good for you. TRAPGX9, happy to be able to help you out. Wait a sec, we are doing the midpoint formula. You could do the distance between 2 points. That's definitely awesome. Of course, anything to do with content you're teaching today, but how to do radicals in the Pythagorean theorem. So Fausto did have a question on the radicals of the Pythagorean theorem. Hopefully I should be wrapping up here in the next 5-10 minutes. So Fausto, if you're still on, if you have some questions, feel free to let me know. And Mauricio, sorry I'm not pronouncing your name probably correctly, but if you have any questions on substitution or anything else that you guys want me to come talk about, I'll be more than happy. So just kind of let me know. I'm going to go ahead and work on these multiple choice, and then if you guys have any questions, I will be helped to answer them. All right. So given that initial point P 8, 8 and Q 9, 17, find the component form of the vector P to Q. So basically, in this case, I'm going to subtract my components 9 minus 8 and 17 minus 8. All right. So here is my initial. Here is my terminal. So you're always subtracting terminal from initial, and then it's always first components, second components. So therefore, that gives me 1, comma 9. Oh, and then find the magnitude. Okay, so it's not this answer. And then the magnitude is obviously going to be, 1 squared plus 9 squared, and then the square root of that, right? So therefore, I can see my answer is going to be C, because 9 squared would be 81 plus 1 squared would be 82. Let u equals 9, 4 and v equal negative 6, negative 9. Find u plus v. Well, again, guys, this is basically just adding your first and second components. So this is basically going to be 9 plus negative 6, and then 4 plus negative 9. So this gives me a 3 and minus 5. Answer A. The next one says, find the magnitude and direction angle for the following vector. Give the direction and angle as an angle on 0 to 360. So we don't want to use negative angles to the nearest tenth for the vector 10, 13. Now, I already know this is in the first quadrant, so I'm not concerned about this. Here's my vector. And if you were to create a triangle here, that's 10 and that's 13. So I know when I'm going to use inverse tangent, though, it's going to give me the right angle in this quadrant. So basically what I'll do is, let's call this alpha. And it looks like the angle is the only one that works, right? So I'll do the angle, because the angles are all different, so I'm going to use the angle here. So I'm just going to do tangent of alpha is equal to 13 over 10. So alpha equals tangent inverse of 13 over 10. So tangent inverse of 13 divided by 10 is 52 degrees and 52.4 degrees. So I can see that obviously the only angle here that's like that is there. If I wanted to find the magnitude, I'm not going to, but that would be 269, which is 100, and then 13 squared is 169. So you can see how that would work out there. All right, and the last one, multiple choice, is rather kind of simple today, is basically just having a multiplier times u. So this would be 7 times the vector negative 3, negative 1. And obviously go ahead and distribute in here. We get a negative 21, negative 7. So therefore, you can see negative 21, negative 7. Answer is D. So voila, there we go, ladies and gentlemen. I'm back. Probably the quickest that we definitely had as far as a live stream. And so, yeah. So if you guys have any questions, I will be happy to answer them. Everything. I didn't see anything else except for something about the radicals and Pythagorean theorem. But if you guys have a actual problem you'd like me to go ahead and do, I'll be able to do that. Let me just go ahead and check the chat real quick, see if there's anything else I missed. But in that meantime, if you guys have questions, feel free to post them. It'd be a great time. Yeah, John, thanks, man. I appreciate that. Try to be cool as best I can. All right, peace out, John. Adios, señorito. Rachel, well, it's awesome. You have in 8th grade, and, a lot of this, to be honest with you, yes, this is in pre-calculus, and if you're in 8th grade, even if you're doing algebra 1 or geometry, but, a lot of the stuff that I discuss in my class, for in pre-calculus, we're referring to, algebra 1 stuff. We're referring to geometry stuff. Just kind of real quick for anybody else that's not in pre-calculus, in my class, I talked about here, I talked about the slope triangle, converting from one point to the next, using that slope triangle, understanding that slope triangle, talking about the Pythagorean theorem, how we created a right angle, and how that allowed us to use, right triangle to use the Pythagorean theorem. Over here, we talked about supplementary angles. So understanding supplementary angles from geometry is very, very helpful. let's see, what else did we get into? The sum, just adding and subtracting basic numbers with negatives using parentheses. That is a very, very, very common mistake that students, even, over here, huge mistake the students make in all grade levels is being careful with those negatives. So making sure you understand that, making sure you understand that the scalar multiple, it's definitely something in Algebra 2 that we talk about as far as like the stretching and the compression of graphs. Well, that's really what that scalar multiple is doing here. But it's a vector, right? So instead of talking about stretching and compressing, graphs, we're stretching and compressing vectors. So a lot of the stuff, even though this is pre-calculus and it might look way over your head, a lot of the stuff that we're doing is just built off of all the stuff you guys have previously learned. So I think that's pretty cool, and that was one of the things I thought was pretty awesome. What year work is this? Victoria asked. Well, this is in pre-calculus, so I have basically sophomores through seniors in my class. So I teach in the high school level from there, but a lot of students come in there from can be from college, or they're taking college algebra or algebra 2, or taking just a separate trig class. So I get a lot of students that use this material for anything else. Mauricio says, can you please do an example in substitution? I do kind of know the canceling the x or the y variable. You do not know the canceling the x or the y variable? Can you please do an example in substitution? I'm not really sure. Like, if you can give me an example that you have, that's kind of a little bit better, because I don't want to just randomly do a math problem that doesn't help you. So if you have something in particular that I can help you out with, that would be greatly appreciated. Thank you so much, Ethan. I appreciate it. And Alok, hi. How are you? All right. I think that was it, so I'm not sure. Oh, Alvia says, do you have any videos on word problems for logs and equations for them? Alvia, no, I do not really believe so. I mean, there are some word problems that I probably have done some videos, but I know that's like not a big thing in my library for that. And just because a lot of the word problems I don't really like for logarithms, they're just, they're just a regular problem wrapped up in some kind of random word problem that is. So I don't see them being like as useful, at least in many textbooks. So, but I know I have covered, some of those. Basically what I would do is a word problem from there is I would just look into extracting the math. So therefore you could do the math and just make sure that your answer makes sense, like any other typical word problem. But typically on those types of word problems, not so much, they usually give you like the equation, whatever you have. So just try to extract the important information you have and go ahead and solve from there. Can I do synthetic division for polynomials? Good. Hey, Kitty Gaming, let me know. So I guess if it's not on focus, I guess I can spend everybody's time going back on there. But either way, I'll make sure I put the homework on my website as well for you. So therefore you at least have that. And then I also know I told you I was going to get the notes and whatever else, which I had to kind of work on some stuff. So whatever else I have, I will make sure I put up there tonight. Synthetic division for polynomials. Sure, that's kind of been a while. That's kind of a good thing to go over. So, I can just do a random synthetic division. That's not as bad. I can do a canceling one. Again, I'm not really sure, Mauricio, what you're looking for as far as that canceling the x and y. So again, if you can let me know on that, I will do it. Let's see, a synthetic division problem. Oh, excuse me, I guess I'm getting tired. This is the first time I think I've yawned on a live stream. So, synthetic. What time is it? All right. So basically, if we're just going to have, I'm just going to make up a random polynomial, x to the fourth. And the crazy thing is you got to actually be careful with these because you can quickly get out of whack with your numbers. But hopefully I don't go too crazy with these. So let's just pretend we have this polynomial divided by, I'm just going to pick something simple, x plus 1. Okay, so obviously here's a polynomial that we're going to divide by x plus 1. Now we could go ahead and use long division, but a lot of times synthetic division helps us, allows us to do this a little A little bit easier with, less kind of work. And a lot of students really struggle with long division. So whenever we have our divisor is a binomial and it's linear, that means it's raised to the first power and it's a binomial, then we can go ahead and apply synthetic division. So if x plus 1 divides into this, which I highly doubt it does because I just made it up, but if it does divide into it, then that's a factor. And remember, we can set our factors equal to 0 to find basically the zeros, right? If I set x plus 1, if this was a factor equal to 0, then x equals negative 1 would be what we call a 0. Now again, we don't know that x plus 1 is the factor because we don't know if it divides into there, so therefore we don't know if x equal 1 is a 0. However, when doing synthetic division, we need to use the 0, not the factor. So we're going to take the negative 1 from this divisor and this split it on the outside. Then what we're going to do is we're going to take the coefficients of our dividend and then place them here. Now, I also purposely left off an x squared term. So therefore, we know that we're going to need to use 0 as a place value there. So we'll do a negative 2. We'll have a 3. No, we got to use your place value. 0, 3, and then negative 1. Okay? So you just take the coefficients, and again, if you're missing a term, then use a place value. And then basically just the flow of this is you bring down the first term, which is 1, and then you multiply on the diagonal. So 1 times negative 1 is negative 1, and then you add on the vertical. Negative 2 plus negative 1 is negative 3. Negative 1 times negative 3 is going to be a positive 3. 0 plus 3 is 3. 3 times negative 3 is going to be a negative 3. 0 plus negative 3 is 0. 0 times negative 1 is going to be 0. Negative 1 plus 0 is negative 1. So regardless of what your answer is, basically the way we like to work this is your last answer is always your remainder. So since this is not 0, that tells us that x plus 1 does not evenly divide into this polynomial. This is going to be your constant term. This is your coefficient of your linear, the coefficient of your quadratic, and the coefficient of your cubic term. So if we wanted to write this as a quotient with the remainder, we'd basically just write this as x cubed minus 3x squared plus 3x. There's no constant here. And that's going to be a minus a 1 over your divisor. Or you could do plus a negative 1 over your divisor, which is x plus 1. So that's how we would write it as a quotient. Obviously, if this was a remainder of 0, then that would mean be a factor. And then what we could do is just set all the factors equal to 0. And so therefore you could find all the zeros, which is what, one of the main practices that we had there. I teach in Jacksonville, Florida at Mandarin High School. Yes, canceling. Do Einstein notation. I don't know what you mean, what you want me to do for that. But if you guys don't have any other questions, again, I try to post on the Facebook. If you guys have questions in the meantime, just to let you guys know, I will be going live again on Thursday. So we're going to do our second day of vectors on Thursday night. So if you guys want to have any questions answered by me, I'll make sure I put up a post here on my Facebook page that you guys can respond to on that, as well as in my YouTube membership. So therefore, you can kind of make sure that you're first in line, because that should be a pretty easy homework as well to be able to help you out with that. So, all right, guys. For some reason, your pen is like really far away from where you're ready. I don't know. It's really weird. All right, guys. Well, I am going to peace out. I still got some grading to do. So, bye-bye. Adios. I'll see you guys on the next one.